Hi children and viewers, in this video I am going to explain about the universal law of gravitation. Universal law of gravitation. So everybody knows the history of gravitational force. What's that? Newton observed is, he was in the garden of apple. He observed that apple is falling from the apple tree, that should be coming onto the earth. He was felt that why it is coming down, why it is not going to up. From that creative thinking, one topic is came, that is universal law of gravitation. Okay children, we know that if you can throw any object, that should be comes down. What's that? We will say that because of gravitational force. Gravitational force. What is mean by gravitational force? Gravitational force is nothing but it's the force of attraction. Force of attraction. So generally everybody can talk about the gravitational force of earth. Then there is no gravitational force for other massive bodies or other planets or other subplanets. Yes, there is force of attraction or there is gravitation for every massive body. Every massive body. That means the body which has certain mass, that should be attracts the another body. Clear? For example, two boys are sitting in a table and they are separated by some distance. Then they have attract each other, but you have to observe, is there any change in their positions? No. Why? Here now I am looking at his position. Behind me wall is there. Wall has some mass. For me also some mass is there, but I am not attracted towards wall. So on this earth every body has some mass and every massive body should be attracts the another body, but we are not feeling the vicinity of gravitational force. Why? Because yes, again every body on the earth should be attracted by the earth. Compared to the earth's gravitational force, the gravitational force of remaining objects is nothing. That's why we are not feeling any vicinity of gravitational force. Here board attracts me also attracts the board, but we are not displaces our places. Why? Because again these two are attracted by the earth. So that's why children, so here by taking all assumptions, Newton proposed one principle, that is universal law of gravitation. According to that, if two bodies are having certain masses and they are separated by some distances, when they are separated by some distances, the force of gravitation force, the gravitational force attracting between these two bodies, gravitational force is always attract, okay? The gravitational force between these two bodies is directly proportional to the product of their masses. Product of their masses and inversely proportional to the square of the distance between them. Clear? For example, we are taking example here, two boys in a bench. Here two boys have certain masses. For example, one boy is having some 40, one boy has some 50. Now 200. So 2000, 50 into 140 means what? Yes, 2000 mass. Here product of mass m1 into m2, 50 into 40, 2000 masses, grams, kgs. But you can compare the 40 into earth mass. Earth mass is almost all 6400 kgs. So that is distance, not about mass. Compared to the earth mass, our mass is very small. That's why we are having more force of attraction due to the earth, but not other things. So here I am going to here topic, children. According to universal law of gravitation, according to universal law of gravitation. Here, for example, we are taking two bodies. This is the first body having mass m1, and this is the another body having mass m2. These two are having some distance of separation of r. Clear? So now there is some force acting between these two. There should be central forces. Central force. There should be here. This is center and this is the center. If you can join the one line, that on that line are some forces acting through that line. That's what is gravitation force is central force. And here, children, gravitation force is conservative force also. So later we discuss what is meant by conservative force. Okay, children, here the gravitational force acting between those two bodies is directly proportional to the product of their masses. Product of their masses, m1 into m2. So this is the first thing. And the gravitational force acting between these two bodies inversely proportional to the square of the distance. Square of the distance. This is the second condition. From these two, what we write, children? F is proportional to m1 m2 by r square. F is proportional to m1 m2 by r square. So this is now called universal law of gravitation. Simply, the force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance. Square of the distance. Here, if you can consider two bodies, if they have more masses, for example, if you consider Earth and Moon, they have more masses and their product also very huge one, then gravitational force also very high. Clear? So, and here that is the first thing. And now the gravitational force is depend upon distance also. If distance is very high, then force is less. Force is less. When both bodies are very close to each other, then the gravitational force is more. If you can consider any particular body, in that there is some interatomic distance are there. Interatomic distance. The distance between the atoms should be called as interatomic distances. For when they have interatomic distance very less, then also gravitational forces acts more, because they are having mass and their distance is less. Then force is more. That means for long distance, you can consider Moon and Earth, then also gravitational force is there, because on that time we will explain based upon their masses. For interatomic particles also gravitational force is there, then we are explaining on the basis of distance. Distance is less, gravitational force is more. That's why the universal law of gravitation is possible for small distances and long distance also. Clear? So this is the, children, universal law of gravitation. What's that? The force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance. Children, I told you, what's that? We are not feeling any sensation of gravitational force. Why? Because we are attracted by the earth. Okay, children, here now to equate them we are using one constant. That constant is here, F is equals to G into m1 m2 by r square. F is equals to G into m1 m2 by r square. F is equals to G into m1 m2 by r square. Here G is what we call proportionality constant. What's that? Proportionality constant. Its value is 6.67 into 10 to the power of minus 11 Newton meter square for kg square. Okay, children, if you want to write the expression for now G, how we can write? G is equals to F into r square. F into r square by m1 m2. G is equals to F into r square by m1 m2. This is the expression for G, proportionality constant. It is also called as universal gravitational constant. So here children, now what is the units of this G? For force already we know that what is that? Newton. For distance, meter square. For mass, kg. Kg into kg. So what's the unit here? Newton meter square for kg square. Newton meter square for kg square. So, and it is known to found that its value is 6.67 into 10 power of minus 11 Newton meter square for kg square. Okay children. Now here if you can consider in that formula, if G is equals to F into R square by M1 M2. So in that formula children, here we will consider, for example, in that formula we will take distance of separation is 1 meter and M1 is equals to M2 is equals to 1 kg. So two bodies of unit masses, 1 kg and 1 kg, and for example its mass is now 1 kg and it is also 1 kg. And what you say, we have selected the distance of separation also 1 meter. Distance of separation also 1 meter. Then what we write? G is equals to F into 1 square by 1 into 1. Got children? We are taking unit massive bodies. That means M1 is equals to 1 kg and M2 also 1 kg. So 1 into 1, 1. And distance of separation also what you take? 1. Then what right? G is equals to F into 1 square by 1 into 1. That means what right children? G is equals to F. G is equals to F. Here what is F? Gravitational force. And what is G? Universal gravitational constant. That means here, now what you have to say? This is the value. That means children, from that statement we have to define universal gravitational constant. What's that? The gravitational force acting between two bodies of unit masses and they are separated by unit distance is called universal gravitational constant. We can define universal gravitational constant also. How? In this formula, if R square becomes 1 and M1 M2 becomes 1, then what right? G is equals to F. G means what? G means what? Universal gravitational constant. Universal gravitational constant is nothing but, or it is equals to the gravitational force. Gravitational force when, if the bodies are having mass 1 kg each and distance of separation is 1 meter. 1 meter. So children, this is about the universal law of gravitation and definition of G. I hope you understand. What is the, children, very simple. Here we are taking what is the universal law of gravitation. The force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between two bodies. Clear? Here let us consider two bodies. We are taken mass M1 and another body mass is M2 and they are separated distance of R. Then what is Newton's law of gravitation? F is proportional to M1 M2 by R square. Then to equate them we are using one constant, that is G. F is equals to G into M1 M2 by R square. This is the equation form of the universal law of gravitation. Okay children, so I hope you understand. We will meet in the next video with some other interesting topic. Bye. Take care children.